Hello everyone, in this video we'll explore topic 9.5 Integrating Vector Value Functions. Alright, you need to explore the integration rules. If the function r of t equals f of t I plus g of t j, where f and g are continuous on the closed interval a and b, and then antiderivative of vector value function r of t dt equals the antiderivative of each of this one right here. Alright, and then don't forget to add c1 I and c2 j for each of this one. Right? When it comes to the definite integral, which means the integral from a to b of r of t dt. It's going to be integral from a to b of f of t dt I plus integral from a to b of g of t dt j. And you don't have the constant right here, right? Because this one is the definite integral, right? You only have the constant when it comes to the indefinite integral, right? Now let's take a look at the first example. Find the antiderivative of this one. Alright, so I'm gonna split this one into two indefinite integrals. So it could be antiderivative of t squared I dt plus antiderivative of natural log of t j dt, right? And then this guy becomes antiderivative of t squared dt, right, I plus antiderivative of natural log of t dt j, right? So remember the antiderivative of s to the n ds, it could be s to the n plus 1 over n plus 1 plus c, right? So it could be t cubed over 3, right? Plus c1 all together I, right? Plus antiderivative of this one, we're gonna calculate this one on the side. So we're gonna let u be natural log of t. Then you have du equals 1 over t dt, right? Now dv equals dt, then v equals t, right? Keep that in mind. Then you have the antiderivative of u dv equals u times v minus antiderivative of v du. Keep this one in mind. Alright, so this guy becomes u times v, which means this guy right here times this guy, right? So it could be t times natural log of t minus antiderivative of v du, v right here and du's right here, right? So it could be t times 1 over t dt j, right? Now I'm going to simplify this one. It could be t natural log of t. This guy and this guy cancel out, right? So you have antiderivative of dt, which is t, right? Don't forget to add a constant c2 all together j, right? So I'm going to copy this one over here, this guy and this guy. And this one is the final answer. Now let's move on to example number 2. Find the integral from 0 to 1 of this guy. Alright, so I'm gonna separate this guy. It's gonna be the integral from 0 to 1 of e to the negative t dt I, right? Plus the integral from 0 to 1 of 1 over t plus 3 dt j, right? Now remember this formula, the antiderivative of e to the as plus b ds equals 1 over e to the as plus b plus c, right? Now a in this situation is negative 1 right here, right? So this guy becomes negative e to the negative t, right? I evaluated from 0 to 1 plus, now the second one for this one is going to be antiderivative of 1 over a s plus b ds equals 1 over a natural log of absolute value of a s plus b plus c, right? So a in this situation is 1, right? So we have 1 over a, which means 1 over 1 equals 1, right? So it could be natural log of absolute value of t plus 3, evaluated from 0 to 1, right? Don't forget I and j. Now I substitute 1 and 0, right? So it could be negative e to the negative 1 minus negative e to the negative 0, right? Don't forget I plus natural log of 1 substitute over here, it could be 4 minus 0 substitute over here, it could be natural log of 3, right? J, right? Now final answer is going to be negative 1 over e, right? This one equals 1, so it could be plus 1 I plus this one right here. I'm going to use log properties, right? So it could be natural log of 4 over 3j, right? This one is the final answer. Now let's move on to the last example. We need to find the antiderivative of this one given the initial condition right here, right? So antiderivative of sine 2t I dt plus antiderivative of 1 over t squared plus 1 j dt, right? Now take antiderivative of this one. Remember, we have the formula antiderivative of sine a s plus b ds equals negative 1 over a cosine of a s plus b plus c, right? So this guy becomes negative 1 over 2, right? Cosine of 2t plus c1 I, right? Now the antiderivative of 1 over 1 plus s squared ds is going to be inverse tangent of s plus c, right? So this guy becomes plus inverse tangent of t plus c2j. Now we're going to use the initial condition right here. Alright, so for t equals 0, substitute over here. So you have negative 1 over 2. Cosine 0 equals 1, so you have only c1 left, right? I plus t equals 0, inverse tangent of 0 is 0, right? Then you only have c2j left, right? Equals the right hand side right here, 1.5 I plus j, right? Now you just equate the coefficient both sides, right? This guy and this guy must be the same, right? And then this guy right here and this guy right here must be the same, right? So you have a system of two equations. The first one is negative 1/2 c1 equals 1/2, and second one c2 right here equals coefficient of this one is 1, right? Now I need to solve for c1. It's gonna be 1 and c2 is 1, right? So the final answer is r of t equals, substitute 1 for c1 and 1 for c2 into this equation right here, and that is your answer, right? So negative 1/2 cosine 2t plus 1 I plus inverse tangent of t plus 1j. Right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand